taking fossil fuels, which, this is in the series dealing with climate change, which I'll come back to in a moment. But world fossil fuel consumption soared with the increase in human population and the increase in the wealth of that human population. And other resources have also soared in terms of their use. For example, our global water consumption has soared in the same period that I'm talking about, in the last few decades of the 20th century. And there's been big consequences, so that we are starting the 20th century with really big problems. For example, land use change. There's various bullets in here which, I have a working assumption that an audience like this can read, so I won't read the bullets to you. But I think I'd probably point to them that, vastly amounts of land were converted to cropland in the decades after the 1950, after the Second World War, and that there has been real problems. So if something of the order of a quarter of usable land is degraded, and about a fifth of all pasture land has been damaged, and there's been massive problems to do with degradation of ecosystems and their general habitat. All of that are the sort of sad and unintended consequences of two good things, essentially the improvement in mortality for adults and children, and the fact that the world was getting more prosperous. And one of the ones that, of course, people are familiar with is the carbon dioxide emissions soaring from 1950 onwards into the period into the 2000s, and that continues on further. And of course it's had consequences for ecosystems. There's three things here, three particular subsets of this slide. One of them is in terms of fisheries, in which fisheries expansion between 1950, in which the degree of shading, the red and the yellow, shows the level of exploitation of fish stocks in the ocean. In 1950, relatively modest. By 2005, almost ubiquitous and big problems in the world. And it's the same thing in the context of biodiversity, big increases in extinctions of animals and plants, and of course the thing that many people are familiar with is the decline in forest cover that's occurring. So that was, in a sense, the legacy of the 20th century. Now, good things happened, but there have been very, very bad consequences of those good things. And just to give you a flavour for it, I talked about inequality, and there's really very sad consequences. The top left slide points to two things. One is the people who, in a sense, don't have sufficient to eat, who are starving, and that is on the left-hand side, and the way that one can calculate it is the biomass index, the BMI index, which points to that about something of the order, if you average across these individual countries, about 15% of people have a BMI index, and this is women, of less than 18, which means they're starving. By contrast, almost the same proportion in the developing world have a BMI index of greater than 30, which means they're obese and will have cardiovascular and early onset diabetes problems in their health. And yet the same countries have almost the same proportion, and it's not that the bigger ones get more to eat. It really is a consequence of a very poor diet. And there are other issues which will come before. There's been a massive urbanization, I'll come to it, and of course there have been big problems in terms of the pressures, and I've referred to those already, on natural resources that are out there. And again, I'll refer to this. At the same time, actually, my background is in science, there's been an enormous explosion, and the bottom right-hand graph points to the number of articles, scientific articles published per year, and showing the way in which they've actually soared in the last decades of the 20th century, but have really started to increase dramatically in the first decade of the 21st. And going forward to 2030, something of the order of 40% more energy is required, something like 40% more food, and something like 50% more water, more available fresh water is going to be required. And at the same time as meeting those demands from the increasingly wealthy population, you had climate change. And I call it a perfect storm because all these things are happening over the next couple of decades. You need to address these food, water, and energy security issues. And at the same time, you've got to be thinking about mitigating and adapting to climate change. I want to go into some of the issues of it. Let's look at energy and climate change first of all. But why are we worried about climate change? Well, one of the issues is to do with natural disasters. And the graph is slightly complex, but let me just point to it. The width of these little squiggles points to the number of natural disasters that have actually occurred. And the blue ones are related to climate and weather, and the red ones are related to geological phenomena, for example, earthquakes or tsunamis or volcanic eruptions. What you can see is that in the case of the natural disasters coming from geological issues, there's really no trend. But the trends that are actually coming from climate-related disasters and weather-related disasters have soared. Now, in part, that's due to an arguably increased vulnerability as more people living in cities. But it's a trend that we have to expect, and all the climate modelling points to the potential for more variability. And one of the things about this is this is a graph of the number of disasters recorded by one of the main reinsurance companies, Munich. And they've looked at natural disasters, and of course a reinsurance company has to think about those. And if you look at the natural disasters, this is the red line that I've imposed there is the changes in carbon dioxide concentration in the atmosphere. So as you can see, they're really quite correlated, but there's an important caveat here because there's a time delay in the climate system. And that time delay points to the fact that in a sense, the weather we're getting now is determined by greenhouse gas concentrations about 20 years ago, because there's a 20-year time lag in which the emissions move through the system, primarily because of the oceans, but not entirely. And so the sort of causal mechanism that I'm pointing to there is the red line where it is generating disasters about 20 years later. And of course, if you extrapolate from now, where greenhouse gas emissions and concentration in the atmosphere are significantly higher than they were in the 1990s, we have to have an expectation that disasters will increase into the future. And of course, this is very much the business of the insurance companies, but it's also our business as humanity. And that is bad enough in the sense if I could persuade the Prime Minister and indeed the heads of state of all the countries attending the climate discussions in Paris, and they were agreed to cut greenhouse gas emissions immediately, what would still happen is that there would be the effect of those emissions occurring over the following couple of decades. And if we extrapolate, and the red line shows the sort of upper and lower expectation of what might be business as usual or indeed worse, you can see that there is a real potential for really quite dramatic changes in weather, which will affect everybody, obviously differentially depending on different geographic regions. And everybody knows about these things, but let me just give you a feeling for the scale of it. And take the US. First of all, it's a big continent and a big country, but things to do with snow, major increases in very high snowfalls. But let me focus on the bottom right, which is essentially Californian droughts. Now, the set of little lines, the black line shows the average over the last 100 years or so, and the red line is the driest period. The blue line at the top is the wettest, and the little line at the bottom, which is noted as 2013-14, that's actually what happened last year. So it's a 1 in 100 year event. It's so dry. And these are the sort of expectations we've got to have for the future. And of course, focusing back, all these things are interrelated. I've pointed to the fact we're thinking about energy and climate change. You can't do them. The top left graph points to the demand in primary energy, almost entirely coming from the developing world. Now, coal-fired power plants, the red shading points to the number of new coal-fired plants that would actually increase the level of greenhouse gas emissions to a level that would be compatible with 450 parts per million. The dark blue shading is those that are actually already under construction, which quite often exceeds that, and the pale blue shading shows the ones that are planned, particularly in China and India. So the idea that we are actually going to see something that is compatible with 450 parts per million or a 2-degree equivalent temperature rise seems to me to be extraordinarily unlikely, unless one can think about ways to do it. And just to give you some flavors for this, the top left-hand is a picture from NASA, which was taken at night from a satellite, and the bright pieces on that are essentially light emissions. And the light emissions point to major cities, but the one, Minneapolis and Dallas are labeled, but the Bakken Formation in North Dakota is one where shale gas and shale oil are extracted. And why is there this bright light patch around there? And the answer is because they're burning gas, because they want the oil, and gas is almost a waste product. And that's the sort of scale that you're observing, and this is a NASA picture. And also, in an ironic way, one of the effects of climate change is that it affects the Arctic rather more, and as the Arctic sea ice has shrunk, it's actually opened up very significant reserves of oil and gas, which are essentially undiscovered and unexploited reserves. And that is going, I suspect, will be a next rush. And finally, coal. There's massive amounts of coal. It seems to me highly unlikely it won't be used. So, where can we have some hope? Well, there are renewables, there is development, there's also nuclear, and the development of these areas and the potential not just to accept carbon dioxide emissions and other greenhouse gases, but actually thinking about some mechanisms and some technology to sequester carbon dioxide, the carbon capture and sequestration, one of the things that have been looked at, but they are pitifully small in the context of the amount that needs to be done. And obviously there's issues to do with various renewables. Solar, wind are the two that we are mainly thinking about in the UK. And there are things that are quite good. This is the approximate change in the cost of solar over something like 25 years since 1990. And coming down, still not down to the scale where it can compete with coal. And cities. This is a sort of extraordinary picture. Barcelona and Atlanta have roughly the same population, about 2.7 million. The grey shading, which is very large in the case of Atlanta, and the grey shading in Barcelona is significantly smaller, that's, as it were, the urban area. And you can see that, albeit they have the same population, the urban area in the case of Atlanta is something like 30 times that it is in Barcelona. And of course, these things, apart from transport things, shows that effectively the carbon emissions from just getting around in Barcelona is 1/10 per capita of what it is in Atlanta. And if you then think about these issues for 1,000 cities the size of Edinburgh that will occur in primarily in West Africa, the 500 cities of 1 million that will be occurring in Asia, the potential for that to be a real mess is very significant. And it's actually a mess not just in terms of the greenhouse gas emissions, but there is enormous problems of pollution. And air pollution is seen as in major cities, particularly in the developing world, is likely to be the main cause of premature mortality. You can not, however, take comfort with this extra premature mortality means that you slow the population growth. It doesn't even scratch the surface. It just means that you actually have a lot of human suffering and unnecessarily suffering in human health. So let me move from energy and climate change to energy and water. Water is probably the area of natural resources that worries me most. This is a busy graph, so let me just start in the bottom left-hand corner, and it shows that that water reuse by agriculture is vastly greater than that for either industry or domestic use. And there's a gap, and that's the top graph, which shows that essentially the supplies as we go out to about 2030, we're going to be about 60% short of available fresh water for activities. And the normal activities, whether it's agricultural, domestic, or industrial. And the top right-hand graph, which is a picture of India, and the level of shading, the red points to overexploited aquifers, i.e. water resources below the surface, and the green is what have those that have been so overexploited they become saline. And to give you a sort of simple analogy of it, the water that is being used for irrigation in northwest India is about 200 years old. So what is being pumped out of the ground is about 200 years old, sometimes larger, and that's used for today's irrigation. And therefore, these aquifers, which are enormously important for agriculture in India, are going to essentially run out. They'll go saline and there won't be a source of water. Massive potential for human tragedy. And just to sort of lighten things, in a sense, probably the maddest piece of agriculture in terms of the conservation of natural resources is the agriculture in Saudi Arabia, which actually is the green circles in which they are using this from oil-driven pumps to actually keep the circles green. This is not advised for the future. So that's one of the problems with water. And these things interact. So I talked about energy, but the energy sector and the agricultural sector accounts for about 15%. The energy sector accounts for 15% of global water use, and agriculture accounts for about 70%. And so the effect of increasing the demand, of meeting the increased demand for energy is likely to mean that we have an increased demand for water. So these things are closely interacting. Let me now move to the issue of food. Again, this goes back to some of the earlier points I've made, is that the increase in human population and the increase in wealth means that food production needs to rise, something on the world as a whole by about 40% by 2030. And that's 15 years away. The change, it's a major issue of meeting that demand, and there have been big developments in agronomy. The bottom graph shows the increase in yield of two major world crops, wheat and maize, and they have done rather well. The increase per hectare has gone up, has improved, but the anticipated demand is just nowhere near the level of the levels that's required. And agriculture, again, it's not just water use, but agriculture is about 25% of global greenhouse gas emissions. Again, I emphasize these things are all interacting. They're interacting not in a comfortable way and mutually supporting. They're interacting in a mischievous way. And the use, there's various things, the energy use in agriculture, but also the chopping down of trees and the changing of the environment to focus on agriculture is by far the largest. But agriculture, if it's to meet the requirements of food and to stay in using the same sort of agriculture that has happened over the last 4 or 5 decades, will mean a big increase in greenhouse gas emissions. So it's a big issue. So if we're trying to feed the world, and we want to feed the world in the same way that we've done in the last few decades, that's going to have consequences for energy use and therefore greenhouse gas emissions. And in terms of climate change, the greenhouse gas emissions, we have a short window to actually see a decline, and the business as usual scenarios are the red shading, and the blue and the green are scenarios which hopefully would be compatible, the blue with 2 degrees, but they involve a decline in greenhouse gas emissions of a dramatic amount from 2020 onwards. If you don't have it, it's going to be very, very difficult to do. And because of the time delays in the system, if you don't see a reduction in greenhouse gas emissions fairly soon, you will see an increase in the accumulation, and that means that our weather for the next 20 years or so is going to be more variable and more mischievous, I think that's probably the word. So finally, what up to 2050? Well, the first thing about 2050 that I think is I should be 105 years of age, so it's down to the younger generation to worry about 2050. But there'll be 2.3 billion more people, could be as high as 4 billion, depending on the demographic response. 70% of the world will live in cities. It will be more prosperous, likely, but there will be potential changes in the tipping points, and the top right-hand graph points to some of the things that actually might happen, like a dieback of the Amazon rainforest, a melting of the tundra with the corresponding increase in methane as the vegetation in the tundra melts. And the basic policy with no change is you're going to need about 60% more food, 55% more water, and 80% more energy. And if you don't see some action, the business as usual scenario is likely we'll have by 2050 about 52% more emissions coming out per annum. So there's some big challenges. There's some big challenges in the next 15 years to 2030, and there's some even bigger challenges as we move out to the 35 years or so to 2050. So it's a tough old world. When I talked in 2008 about the perfect storm, I kind of hoped that things would improve. I have to say they've not.